Let's shift gears a little bit and talk about simplifying radicals and what to do when those radicals are actually imaginary numbers. So what we want to do is, again, practice two things. Is first of all, how do we simplify a radical? And then what do we do when it's an imaginary number? And notice I've given you some reminders down here at the bottom for imaginary numbers. We're going to write each expression in terms of I, simplify as much as we can. So let's start with an easy one, 50, because that one doesn't have a negative, and so it's a little bit more straightforward. And what I'm doing is I'm thinking about perfect square numbers, because this is a square root. There's an imaginary 2 here that we don't see. Later on we'll talk about cubed roots and fourth roots, etc. But right now it's just a square root. So I'm thinking about the perfect square numbers. 1 squared is 1. 2 squared is 4. 3 squared is 9. 16, 25, 36, 49, 6, 7, 8 is 64, 9 is 81. You get the idea, and I could keep going and going. So what I'm doing is when I'm simplifying a radical, I'm looking for, are any of these numbers a factor of the number inside the radical called the radicand? So for instance, looking at 50, I could break 50 into 5 times 10, but that wouldn't help me because 5 is not up here and 10 is not up here. However, I could instead break it into 25 and 2 because 25 is in my list of perfect squares. Now, why would I do that? Because I can find the square root of 25, which is 5. So if I want to simplify this, my solution is 5 radical 2. So the 5 that came outside the radical, because I took the square root, and the 2 that stayed in, because if it's the square root of 2, it's like 1.41, etc., not a whole number. So my answer is 5 radical 2. So that's how we simplify a radical. Same thing with 64. If you'll notice, 64 is actually one of my solutions. So this one's very easy. The square root of 64 is just 8. I don't have to do anything crazy. That's my answer. But now let's take a look at 90. And notice there's a negative. But we have to differentiate between when there's a negative on the inside and when there's a negative on the outside. So this is almost like saying -1 times the square root of 90. So we don't have to worry about the negative till we get to the end. So I'm just going to look at 90 and say, hey, what goes in there that's up here? And in this case, that's 9. So radical 9, radical 10, radical 9 turns into 3. So my answer is going to be 3 and radical 10, but also the negative. So -3 radical 10 is my solution. So now let's look at the numbers on the right side here, which are a little bit different, because the numbers on the right side, we are dealing with negatives on the inside. So let's remind ourselves down here that if we have the square root of -1, that turns into an I. If you have an I squared, you get -1, which would make sense. The square root of -1 times the square root of -1 would be -1. We're not going to end up with any of those here. So essentially what we're saying is, hey, if there's a negative on the inside, move an I to the outside and then just do what you would normally do. So when I break this one down, I'm going to think of this as the square root of -1 times, and then again I'm looking up here and it looks like that would be 4 and 10. So if I multiplied -1 times 4 times 10, I would get -40. So why did I do that? Because the square root of -1 is I. The square root of 4 is 2. The square root of -10 I can't do anything with, so my solution is 2I radical 10. That's my final answer. Similar with radical -32, because there's a negative on the inside, there's a -1. I'm going to circle this negative here because that negative's on the outside and I need it at the end, but not until the end. 32, I could take 4 times something, but really I want to look at 16 because this is 16 times 2. So it's always best to get the largest number that goes into it that's a perfect square. So the square root of -1 is I, the square root of 16 is 4, and so I'm going to end up with a negative I and 4 and radical 2. So -4I radical 2 is my solution. So a lot going on in that one. Last one, negative radical 16. This one I'm just going to break into two parts because I know that the square root of 16 is 4. I know that the square root of negative 1 is I, so this answer is just 4I. Here are a couple of examples for you to try on your own, so press pause, try these 3 questions, then press play to see how you did. So for my first one, I have radical negative 36. So again, if I were to break this down, I would say negative 1 times 36. 36 is great because it's already a perfect square. The square root is 6. The square root of negative 1 is I, so my answer is 6I. For my next one, negative radical negative 14. So negative 14 is negative 1, and then I could break 14 into 7 and 2, but again, that doesn't help because 7's not a perfect square and neither is 2. So really, I'm just dealing with a negative I radical 14 because I can't simplify radical 14 any further. Last one, 75. Again, I'm going to break this into 3, so radical negative 1, which will get rid of that negative. And 25 is a perfect square that goes into 75 and 3. So this one's 5, this one's I, and this one's radical 3. So my answer is 5I radical 3.